Okay, so hello everyone. For those of you who don't know me, my name is Michael Malco, and I'm the project leader of the Electric Sports Bike project. I work along with former students at Burn Community College, which are
I am Don.
Edgar Hernandez.
Erin.
Patricia.
yeah, and we also have 4 more people working on it, but they're not with us in summer too. So I would like to start this presentation with going over the updated poster from STEM-C Squared. As you can see, these are all the components that are required for electric motorcycle or electric vehicle in general. As you can see, there is a battery, there is a motor, which we have right over here. You can take a closer look at it later. The controller for the motor and the battery management system for the proper management of the battery. And in summer 1, we had a lot of issues with our electrical components, with our batteries mostly. And by the end of the summer 1, we actually got everything to work. And you can see our second demonstration of the motor spinning. This is Louis using the throttle for the motor. This motor can go up to 45 RPMs, so it doesn't use full power right now. The full power of the motor is 20 kilowatt. However, we were drawing only 180 because there was no load on the motor, and it cannot go above 4,500 RPMs. And that was the progress, like the biggest progress for the summer 1. Yeah, perfect. And when we got our electrical system to work, we started manufacturing all the components to mount every single electrical component on the motorcycle. And as you can see, this is the process of using milling machine in Tech 101 with the help of Mark Balzaret, who is our mentor. And we used the knowledge that we got from mini course, Introduction to Machining Tools, during the summer 1. And this is what I was able to do with the motor mount. Then he was very nice to help us by welding the motor together, and yeah, that's pretty much it.
Okay, so this is the BMS of the bike, the battery management system. And my job is to design a cover for it. Since the battery is going to be covered, the BMS will be on the outside. We didn't want it to be exposed. So I'm using Fusion 360 to create the design for the outside. And right now, we're just building it out of cardboard just to see how it physically looks and fits inside the bike frame. And then once it's done, we're gonna 3D print it.
And then for the battery, we have almost like a T-shape looking ones, and then so this is the aluminum bars that we have, and we had to thread the holes in between the plate, the triangular plate that we have. And this triangle plate is to support the bars together, and then and this will be looking like this to be within the battery.
So for the design aspect of the bike, we wanted to keep 2 things in mind: simplicity and efficiency. And because we wanted to have a very simple design, yet we wanted to also incorporate some kind of dimension, so we worked with geometrical shapes to finish this kind of look. Because we're also manufacturing the bike with fiberglass, we also decided to keep the gas tank and the seat to minimize the overall cost and size of the material being used. As for efficiency, we created openings, as you see up here and also down here, to help cool down one of the major components. Like the openings up here would help cool down the battery pack and also the BMS, whereas this opening right here would help cool down the motor directly.
So we're at our end game, and our future plans are to replace the tires, finish the brakes, and finish manufacturing the mounts. And from there, we're going to try to run the bike, and hopefully it will run.
I believe that's it. Thank you everyone for this. However, I would like to give a huge round of applause to my mentor, Mark Bozzelred, because without him, this project would never be where it is right now.